pressure, it's a sort of natural phenomenon of gases or whatever that they're trying to make a lower pressure. They try to take up as much space as they can.
Yeah.
Okay? So they're actually giving their energy back to the plunger by pushing it back out.
Okay.
And when the pressure's dropped back down again, then it will stop.
Yeah.
Okay?
Yes.
And that happens, if you think, you know, when you watch the weather forecast,
Yeah.
and they talk about high and low pressures.
Yes.
Yes. Well, that's exactly the same thing. In the weather system, if you have high pressure, that's gas pressure, isn't it? Because it's the air. If you have high pressure, that high pressure is always trying to balance out with an area that's lower pressure. So when you've got a high pressure system, the air is trying to move away from the high pressure to even that pressure out again.
Yes.
That's why you get these high pressure systems, and then they gradually fade away. And if you get a low pressure system, the air flows into it to try and raise the pressure.
Yeah. Okay.
So actually, what we're talking about here has a lot to do with how the weather works. Okay. So always trying to get from a higher pressure to a lower pressure if they possibly can. The gases do. Does that make sense?
Yes.
Yeah?
Yes.
Okay, good question. Right, let's have a think about one more thing then. So, how about this?
So it spreads around by first the gas.
Yeah?
From the socks is spreading around the room, and like how there's a bottle, the door was not open, so the gas was trapped around, so it could not leave the room.
Yeah.
Yeah.
So how did it get from his feet over to the lady by the door?
It spread around. The particles
It is spread around. That's right. It's a process called diffusion. Okay. So I don't know about you, but I've got a son. He's quite a bit older than you, and sometimes he will get up in the morning and he's got his horrible deodorant smell, his Lynx or something, and he sprays that on himself, and in no time at all I can smell it downstairs.
Yeah.
Yeah. So the reason that happens is kind of like what we talk about the gas pressure. So the process by which a smell spreads around within a room or a house or whatever is called diffusion. And diffusion is also to do with it's not pressures, it's called concentration. But what happens is if you imagine those green dots are particles of my son's air freshener, my son's deodorant. When he sprays it, there's lots of them in a small space.
Yeah.
But then gradually, because all of the particles are whizzing around all the time anyway, they will start to spread out from each other. So they go from what's called a high concentration, where you've got lots of them in a small space, to being spread out, where we say it's a low concentration. So that's how they spread, is by the particles bumping into each other and moving around the room. But the smell is not going to be as strong over here in the low concentration zone as it is in the high concentration zone.
Yeah, okay.
Yeah? So you spray out the particles, they're all whizzing around, bumping into each other, and they gradually just go on and spread out into the room. Okay, so that's called diffusion, and that can happen really easily in a gas, and we know that because we can smell good smells and bad smells pretty fast, can't we? So, do you think you can get diffusion in a liquid?
Yeah. Yes.
Yeah.
Yes.
Okay.
Because if you pour it on a table, it will move around.
Yeah, that's more because it can flow.
Yeah.
But this is something you could try if you've got some food colouring at home. You could try this yourself. So just get a glass of water, and then just put a bit of food colouring in, and then watch what happens. And what you find is you start off with kind of a blob of it, don't you?
Yeah.
And then you can watch it gradually over some minutes spread itself out within the water, so that it ends up being just the same colour all the way through.
Yeah. Yes.
Yeah? So you could try that for yourself, but that's because of diffusion in the water. And it's exactly the same thing. It's like the particles are bumping into each other, and they gradually get spread out within the whole volume of water that you've got there.
Yeah.
Okay? And then one last thing. Okay, I'm going to show you. So, do you remember we were talking about the gas particles? And when we gave the gas particles more heat, they got more energy. And what happened to them when they have more energy?
They start spreading around more. They get
That's it.
faster to get. Yeah.
Perfect. Yeah, they get faster, don't they?
Yeah.
Whizzing around, and they're bumping into each other more because they're moving around more. Okay. So, diffusion. How do you think the temperature might affect diffusion?
Oh yes. So say, I have an example. But say if you get water.
Yeah.
Yes. And you put it in a cup, and it's hot
Yeah.
water. Will the steam will come out of the water, and it will spread around. But if you put it on cold water, for example, it won't like the gas won't come out, and it won't move because there's not enough energy. So
That's true. Yeah. So if you've got a higher temperature, you've got more energy. Yeah.
Yes.
So if we're just thinking about having, it's another film, but you don't need to see this. So you could try this one at home as well if you want to do a little scientific experiment for yourself. So I said you could do it with a glass of water. Tell you what you could do with Dad's help. If you get two glasses the same, and put the same amount of water in each, but one of them you just put it in straight from the tap,
Yeah.
and the other one, if you've had some water from the hot tap instead. Okay, so some from the cold tap, some from the hot tap, and then you put some food colouring in both of them, about the same amount, and then you can watch what happens. And what you should find is that the one that's got it's got the cold water in it, will take longer for the colour to all spread out.
Yeah. Yeah.
Than it will in the one from the hot tap.
Yes.
And that's because particles in the hot water are moving around faster, they're bumping into each other faster, and so they mix all the particles of dye around more rapidly than in the cold water. Okay?
Yes. Okay. Yeah.
So that's something that. Yeah. Okay. So, how does that? So that's what I wanted to tell you about today in terms of solids, liquids, and gases. So, what did we learn about? We learnt
About the fusion.
that they have different properties.
Yeah. About the properties.
Everything's made up of particles.
Yes.
Yeah.
About the compression.
Yeah.
The compression. Yeah. About
Yeah.
about the diffusion of the liquid, and on the video it showed that liquids can become solids, such as an ice cube, it can become a solid by freezing, and
Yeah.
a gas and a liquid can become a gas by steaming it. Yeah.
That's right. We didn't actually talk about that yet, did we? But you're right. Those three states of matter, they can change from one to the other, can't they?
Yeah.
Yeah. So that's the sort of next topic that you would look at in the book. Okay. So that's what I was going to do with you today. Is Dad there? Does he want to have a chat?
He's over there somewhere.
He's over there. All right. Okay. So that's if I was that's kind of how I would try to.
How was the
Hi there.
lesson? Was it alright?
It freezes. Yeah.
Sorry, what did you say?
I said, how was the lesson?
Oh, it's fine for me. I don't know how it was for Deborah.
Yeah, it's good.
Yeah.
Yeah.
So what I would try to do because just going through